Alright, so we've done the first part of chapter 12, or section 12.1, and it's define and use sequences and series. So what if I add up all the terms of a sequence together? If I do that, then I get what is called a series. So if I'm looking at my first example, I have 2 plus 4 plus 6 plus 8. Now, remember that when there's not when there is a stopping point, we call that a finite series. And for here, it keeps going on and on forever. So again, it's an infinite series. And usually we're going to write these in what is called summation notation or sigma notation, either one. The reason you can use sigma notation is because this picture here, or this shape here, means sum, and it's the Greek letter sigma. So you can use this value here. Now, I need to first come up with my rule, and I'm going to find my rule the same way that I found my rules in my sequences. So I have, if I made this an XY chart, sorry, it's going to be horizontal, then I have 1, 2, 3, and 4. And if I look, I notice that I'm multiplying each one of these numbers by 2. So my rule is going to be 2n. So if I'm writing this down here, and I look at this, I'm going to have my sigma, and then I'm going to have my start of my domain. My domain, again, remember, is my x values. So I'm going to have n equals 1, and then I'm going to have my ending domain, which in this case is 4, since we have a finite series. And then I have my rule, which is 2n. And then we're going to do the same thing over here with our infinite series. I have my sigma. The start of my domain is still 1, because it looks the same as it does over here. So I have n equals 1. But I don't have an ending, so I'm just going to put infinity up here, and then my rule is still 2n. Okay. On to the first example. It says write a series using sigma notation. So we're going to figure out our rule first, just like we did with sequences. So I have my XY chart, and I have 1, 2, 3, and 25, 50, 75. Now the reason I stopped at 75 is because there's some values in here, but I don't know what they are. So I'm going to find my rule just off the finite pieces that they gave me. So if I look at this, I'm saying, okay, something times 1 equals 25, 2 times something equals 50, and 3 times something equals 75. And hopefully you figured out that if I have f of x, then I do 25 times my x to get my y value. So now I can figure out what if my last number is 250, because my last number in my series is 250 in this case. It is a finite series. So how I can figure out this is you can say, okay, well if I multiply by 25, then I have what times 25 equals 250, and hopefully you said 10. If you couldn't do that in your head, or if this was more complicated, you could have done 250 equals 25x, and divide both sides by 25. So you get 10 is equal to x, and you could have figured out the last term in your series. So if I were to write this in sigma notation, I have my sigma. I started at 1, so I have n equals 1, and it goes to 10. And then I know that I used x here, but since I used n here, I'm going to write my rule is 25n. Okay, so now I have my next one. And let's pretend this is 1 over 1, because it is. So I have xy, and this is an infinite series. So I'm just going to use the numbers that I know, and I'm going to say my x values are 1, 2, 3, and 4, just like I always do. And then I have 1, 2, 4, 8. Now, like I said before, you can look at the differences. So this is a difference of 1, this is 2, this is 4, then this is 1, and this is 2. Notice that I never get anything matching. I go all the way out to one term. So I'm going to assume that I'm going to have 1 on the top, because 1 is consistently on the top. And then on the bottom, I'm going to have some value to n, and then maybe a minus or plus something over here. So I'm going to look at it and say, okay, so if I have 2, Then I have 2 to the first power is 2. But now I need to figure out 1, and if I have 1 to the first power, I get 1, which is good, so now that works there. Now, if I go here, then I have 3 to the first power is not equal to 4. So I'm going to look at it again and say, okay, what if I start with 2? So I have 2 to some power equals 2. Okay, so 2 to the first power equals 2. And then 2 to the what power equals 1? What about 2 to the 0 power? So then I can maybe add a minus 1 here. So then I have 2 to the 1 minus 1, which is 0. So 2 to the 0 power is 1. Sweet. And then I have 2 to the second power minus 1. So 2 to the 2 minus 1 is 1. So that's 2. Good. And then if I have 3, I have 2 to the 3 minus 1. So I have 2 squared, which is 4. Now we're talking. And then it works again with 4 over 8. So my rule is going to be this. Let's pretend that's an x. So now I can do my summation. So I have n is equal to 1, because remember I started at 1, and then it goes to infinity, and then my rule is 1 over 2 to the n minus 1, and the n minus 1 is all of the exponent. Okay, last 2 examples. It says find the sum of the series. So this is where I'm just going to add stuff up. So I'm going to start at 3 for my k value, and I'm going to end at 5. So I'm going to have 3 times 3 squared minus 7, this whole thing, plus, now I'm going to go to 4, so I have 3 times 4 squared minus 7, plus, then I have 3 times 5 squared minus 7. And it says to stop at 5, so since I'm at 5, I can stop. So now I have 3 squared, which is 9, times 3, which is 27, minus 7. This is 20, plus 4 squared is 16. 16 times 3 is 48. So I have 48, and then I have minus 7, which is just going to be 41. And then I'm adding again. 5 squared is 25, plus 3, or times 3 is 75. 75 minus equals 68. So I have 68 here. And then I have 20 plus 41, which is 61, plus 68, which is equal to 129. So my summation is 129 for this series. So now one that's a little bit simpler. My k value is just, or my rule is just my k value. So I have, starting at 2 and going to 7, I have 2 plus 3 plus 4 plus 5 plus 6 plus 7. So then I have 2 and 3 is 5, 4 and 5 is 9, 6 and 7 are 13, and then this is 14 plus 13. Don't forget your plus signs. 14 plus 13, which equals 27. So my summation of this series is 27. So looking back, basically what I had to do is just find my rule and then figure out where the starting and stopping point are. Besides that, it's the exact same thing as a sequence. All right, have a good night.